In this video, we're going to take our completed farming RPG project and we're going to add a day and night lighting cycle to it. If you're interested in the course, full details are in the description in this video, and you can get the course at a discounted rate from Udemy using the promotional codes provided. So let me just run the game to show you what you should have as a finished project from the course. So we've got our farmer character here, and he can walk around and go into different locations. So you should be familiar with this. So that's what we've currently got. And I'm just going to give you a quick demo now of what we're going to do in this lecture and how the day and night cycle is going to look. So here's the game, and straight away you'll notice that we're in the very latest tech release version of the Unity editor, so Unity 21.1.17 F1. And we've gone to that just so that we can demonstrate that everything works fine with the latest editor version. And also we're going to use the universal render pipeline. So if I just click on the play button, so the game looks very similar to the way it did before. And you'll just notice a few of these jack-o'-lanterns scattered around, and the game behaves in exactly the same way. Now, if I advance time by pressing the test time advance key to say about 4:30, I'll say to 5 o'clock, and you'll notice now things are starting to get a little bit darker. And as they get darker, our lanterns start lighting up. And you'll also notice if I go in the cabin, I've got this light now on the table. You'll notice a little bit of flicker in there, a flickering effect, and with the lanterns. Now we've set up a time schedule. And it isn't just a simple time schedule. This is a time schedule that you can alter by season as well. So in the summer it stays lighter, whereas in winter it gets darker a lot earlier. So at 6 o'clock we're going to go a little bit darker still. As you can see, we're fading into the sort of next level of darkness. And for the spring, I've set it to go the darkest at about 7 o'clock. So I can just skip the time forwards to 7 almost. There we are, 10 to 6. Now 7 o'clock, you'll notice we'll fade into our sort of darkest that we're going to have it. And you get this really nice lighting effect now. And we're using the Unity 2D lights to do this. So everything works the same, but we've got these new 2D lights that add a really nice lighting effect to the game. And we're also using the 2D lights to fade in the environment lighting as well. And if we have a look in the cabin now, you'll see the cabin's lit by this solitary lamp. So it's a bit dark in the corners, but it still looks very effective. Okay, so this is really what we're going to be doing. And also, I won't demonstrate it now, but when we get into the winter, the environment light gets a lot darker earlier on. So that looks really good. So that's what we're going to be doing in this lecture. So I'll see you there. So the way I'm going to implement the day-night lighting cycle is I'm actually going to take the current project and I'm going to move it to the latest version of the Unity editor that is available as of recording this video. So what I'm going to do is I'm going to take the current project and I'm going to move it to version 2021.1.17 F1. And then once I've done that, I'm going to implement the universal render pipeline and upgrade the project materials to use the universal render pipeline materials. And one of those materials is a sprite lit default material. And the latest version of Unity also includes 2D lights. And we're going to use those to actually implement the day-night cycle. So let's start by moving the current project to a new editor version. So the way I'm going to do that is initially just open the project in the new version. So this is the Unity Hub, and at the very top here, you can see this project called Farming RPG Course Extension Lectures. So I've copied the project as it is at the end of the base course, and I've renamed it Farming RPG Course Extension Lectures. And what I'm going to do is I'm going to include the upgraded project as part of the course materials. So if you look at the course materials, there'll be a zipped file that you can download with the end result of what we're doing here. So as you can see, the project currently has the editor version 2019.3.7 F1. And what I'm going to do is I'm just going to change that to the latest stable sort of released version that I have, which is 2021.1.17 F1. I'm going to just open that with this version of the editor, and it basically comes up with a verification message, and I do want to change the version. So I'm just going to let Unity now open that new version. It comes up with this message here, basically saying you can't go back, so make sure everything's backed up. So I'm going to click on continue, and it will just go through now and basically resolve all the packages in my original project to match the new editor version. So this can take a little while. So I'll rejoin you once this is done. So here we have the project opened in Unity 2021.1.17 F1. And you can see that everything seems to have loaded fine. And I've just got a message down here about the Visual Studio Editor package, and there's a later package available, so that's fine. But let's just run the game as it currently stands without doing anything, just to see if it runs okay. And here you can see the game is running absolutely fine. So I've taken the project from the original course and I've literally just opened it in the new version of the editor, and it works pretty much straight out without any changes. So that's great. So this is the version of the project that's currently using the built-in renderer. And what we want to do is we want to use the new universal render pipeline. So it's very easy to do that. So what we're going to do is we're going to head over to the package manager. So go to Window Package Manager, and you might just need to click this refresh button at the bottom here so that everything shows. So we had a message about the Visual Studio Editor, so I'm just going to go and upgrade that to the recommended version. And if there are any other upgrades available, they'll show with this little upwards arrow next to the package. So I'm not going to upgrade anything else. And we're actually not going to be using the 2D Pixel Perfect package because this only relates to the built-in renderer. And there is another version that we can use that is usable with the Universal Render Pipeline. So I'm just going to go down now and install the Universal Render Pipeline. So I'll just scroll down to the Universal Render Pipeline package. So that's currently at version 11. And then I'm just going to click on install, and that'll just install the Universal Render Pipeline. Okay, that's done. So I'm just going to close the package manager. And then what I'm going to do is I'm going to create the rendering pipeline assets that we need. So I'm just going to go over to the assets folder, and I'm going to create a new folder. So right click, create folder, and I'm going to call that rendering. And then I want to create the pipeline asset, the universal render pipeline. So I'm going to right click on this folder, create, and then we need to find the section that's called rendering, and then universal render pipeline. And then we want the pipeline asset, and then in brackets 2D renderer. So I'll select that, and I'll just accept the default name by pressing return. And you can see it creates two assets for me. I've got the pipeline asset, then I've got a data asset for the 2D rendering. So the first thing we need to do is we need to get the project to use the universal render pipeline. And the way we do that is through the project settings. So I'm just going to navigate over to edit and then project settings. And then in the graphics section, there's a field here that says scriptable render pipeline settings. So what I want to do is I want to drag the asset that we just created into this field. So here's the asset I created. I can just drag it into that field. And then straight away it picks up the universal render pipeline, and some of the options then are sort of hidden because they're configurable within this 2D configuration asset. So I can close the project settings. Then if I go over to this universal render pipeline asset underscore renderer, I can change some of the settings that we previously set up in the project settings in this screen in the inspector. So the main one that I need to change is the transparency sort mode. So we want a custom axis sort on the y-axis. So if we select custom axis, it automatically sets it to be on the y-axis. So it sets y to 1 and then the other values to 0. So that is the main setup done. So now the project is using the universal render pipeline. But one thing we need to do is our previous project was created using materials that were designed to be used by the built-in renderer. And what we need to do is we need to upgrade those materials so that they can be used with the universal pipeline renderer. And in particular, we want the materials to be able to be lit materials, so we can light them with 2D lights. And actually, it's quite a simple thing to do. So the first thing I'm going to do is upgrade any materials that are currently in my projects folder here. And the way you do that is go over to Edit. We go all the way down to Render Pipeline, to Universal Render Pipeline. And then we want to upgrade the project materials to 2D renderer materials. So this will update any materials in our projects folder to materials that can be used with the 2D renderer as part of the universal render pipeline. So I'm going to select that and just click on proceed. And then it will just go away and update all of those materials. And you'll notice a couple of our characters here have turned black, so that's fine. It's nothing to worry about. We'll sort that out in a minute. And then the next thing we need to do, so that's upgraded any materials in our project folder. The next thing we need to do is upgrade any materials that are already being used in our scenes. So to do that, what I'm going to do is make sure that all of the scenes are loaded. So the persistent scene is loaded. I'm going to load the farm scene, the field scene, and the cabin scene. So have them all loaded and open at once. Then I'm going to go back to the edit option. I'm going to go down to render pipeline, universal render pipeline, and then select this option, upgrade scene materials to 2D renderer materials. And that'll go through and update any materials in these scenes that are loaded. And then the message here says the upgrade will change the material references of the sprite renderers in currently open scenes to a lit material. You can't undo this operation. Make sure you save the scene for proceeding. So that's fine. We're happy with that. We can just proceed. Okay, so everything's gone black, but that's absolutely fine because what's happened is all of our materials have been upgraded to materials that need to be lit. So they're sprite lit materials, but we haven't got a light source in our scene. So let me just save all of these scenes here. And then what I'm going to do is I'm just going to unload them. So unload scene, unload scene. And then what I'm going to do is I'm going to add a global 2D light to each one of our scenes. So in our farm scene, I'm going to right click. I'm going to add a game object, go down to light. And then you've got some new options here. You've got a global light 2D, a spotlight 2D, sprite light 2D. So these lights are designed to work with our lit sprite materials. So I'm going to add this global light 2D. And I'll just call that global light 2D. And still everything is black. But what we need to do is we just need to make sure that this light is affecting all of the layers, the sorting layers that we want. So if you go over to the right here, you've got this target sorting layers option. So rather than default, I'm going to select all. And then magically everything then is visible in our scene. So let's just Control S to save that. I'll unload the farm scene and I'll do the same for the field scene. So we want to add a global light 2D. I'll just call that global light 2D. And then we want that to basically target all the sorting layers. So we can save that, unload it, and then just do the same for the cabin scene. So let's just add the global light 2D. Just rename that. And then make sure it's targeting all of the sorting layers. So Control S to save that. And then I'll just unload everything. So we've got no scenes loaded, we just got our persistent scene. So if I start the game, you should see the game working exactly as it did before. So let's just press on play. And here we are. So everything looks the same, but we've actually made a big change behind the scenes. So we've implemented the universal render pipeline now, and we've created a 2D rendering asset that pipeline is using. And we've also upgraded all of our project materials to use materials that work with the universal render pipeline 2D renderer. And these are all lit materials that we've created so that they respond to the 2D lights. So you can see everything looks the same, but it's a massive step forward. So, okay, so let's just go back to the Unity editor. So there's a couple of other things that we just need to change that are affected by implementing the universal render pipeline. And the first one is pixel perfect. So if we just go to the main camera, we get this message here against the pixel perfect camera component that this isn't compatible with the scriptable render pipeline. So this is a bit of a current issue with Pixel Perfect and the Universal Render Pipeline, because the Pixel Perfect camera component was designed for the built-in rendering pipeline. So what they've done is they've included an experimental component, which has been there for a long time. So it's sort of the main component to use for Pixel Perfect with the Universal Render Pipeline. So if we just go to Add Component and then search for Pixel Perfect, you can see we've got this additional component here called Pixel Perfect Camera in brackets experimental. And this is a component that's provided as part of the Universal Render Pipeline package. So I'm going to select that. And then I'm just going to configure this in exactly the same way as the original component that we had. So the assets pixels per unit is going to be 16. The reference resolution is going to be 480 by 270. And we're going to crop the frame in the X and Y, and then we're going to stretch fill it. So this is now set up in exactly the same way as the original component. And what I'm going to do is just delete this original component. So just click on Remove Component. So that's the Pixel Perfect camera now solved for the Universal Render Pipeline for the main camera. I'll just Control S to save that. And there's one more thing we need to do, and that's on the Cinemachine camera. So the player follow virtual camera, there's a component that's designed for the Cinemachine camera to work with Pixel Perfect. So what we're going to do is we're going to go down to extensions, add extension, and then just select the Cinemachine Pixel Perfect component. You can see it pop up at the bottom here. So this will work with the Universal Render Pipeline Pixel Perfect component that we just added to the camera. So I'm just going to Control S and save that again. And I'll just run the game to prove that everything is still working fine. And you can just change this target resolution here to Full HD. And it's working absolutely fine. Pixel Perfect's working. The player's moving as before. All of the graphics are rendering properly in all of our different scenes. So that's really good. Okay, so that's the base setup done. Now, all we need to do now is set up a script to handle a day-night cycle. So let's just navigate over to the scripts folder. And I'm going to create a new subfolder in there called lighting. And I'm going to put the lighting related scripts in there. Now, a normal sort of day-night cycle often just has the lights dimming at night and then becoming bright again in the morning, which is fine. That's sort of what we want. But in the real world, the sunset and sunrise times are also dependent on the season. So we're going to implement something a little bit more sophisticated. We're going to allow the lighting to be varied depending on the current season. And to enable that, what we're going to do is we're going to set up a scriptable object class that basically holds the schedules for the lighting. So let's just go over to this lighting folder. I'm going to right click and create a C# script, and I'm going to call that lighting schedule. And I'm just going to double click on that to open it in Visual Studio. So if you want to, you can prefix this with SO. I haven't done so in this example, but what we want to do is we want to have this inheriting from scriptable objects rather than mono behavior. So we can just add that. And we're going to add the create asset menu attribute so that we can create this scriptable object from the menu. So I'll just add that at the top. And I'll get rid of these. And then we're going to add a struct. And the struct is going to be a struct that holds details about our lighting brightness. So I'm just going to set that as system serializable so we can populate that in the Unity editor. And you can see here we've defined a new struct called lighting brightness. And then we've got 3 fields in the struct. We've got our season, we've got our hour of the day, and then we've got a light intensity. And then all we're going to do is we're going to set up a member variable in the lighting schedule scriptable object class, which is an array of type lighting brightness. So I've just called that lighting brightness array. So what we're going to do is we're going to create scriptable objects in our editor for our lighting schedules, and then populate the times and the seasons for each of those schedules and how bright it should be. So let's just Control S to save that. Then I head on back to Unity. Then I'm going to go up to the scriptable object assets folder, and I'm going to create a new folder in there. I'm going to call that lighting. And then in this lighting folder, we're going to create a schedule for our main outdoor environment. So I'm going to right click, create scriptable objects. And then we've got this new lighting option here, and then lighting schedule. And I'm going to call that outdoor environment. And then you can see we can populate an array here of values. So I'm going to add a value here. And then if we just expand it out, you can see we can define a season, the hour, and then the light intensity. So 2D lights have a light intensity. So by varying what we specify here, you can control how bright a light is. So this outdoor environment schedule is going to target the global light. So what we'll do is we'll set up all the values that we want for a spring season. So at 5 o'clock in the morning, we're going to have the global light intensity at 0.85. And then at 6 o'clock in the morning, we're going to have that light intensity at 0.95. And then at 7 o'clock in the morning, we're going to have the light intensity as 1. And then at 5 o'clock, we're going to have things starting to go dark again. So at 5 o'clock, we're going to have the light intensity to 0.85. At 6 o'clock, so 1800 hours, we're going to have the light intensity at 0.5. At 7 o'clock, we're going to have the light intensity at 0.2. So that's as dark as we're going to have it. So we're going to leave it so there is a little bit of light so we can sort of just about see the player, but that 0.2 is pretty much complete darkness. So that's everything done for spring. So what we're going to do now is just do the same for our other seasons. So let's set up the schedule now for summer. So during the summer, it gets lighter earlier and stays lighter for longer. So at 4 o'clock in the morning, we're going to have 0.85 light. At 5 o'clock in the morning, we're going to have 0.95. And then at 6 o'clock, we're going to have the intensity of 1. And then we're going to have things starting to go darker a lot later. So for the summer, we're only going to have things starting to go darker at 9 o'clock. So we'll set that to 0.85. And then at 10 o'clock, we're going to set that to 0.5. And then it's not going to be until 11 o'clock, we're going to set that to 0.3. So slightly brighter than in the spring. So that's the summer done. And then what we're going to do now is set it up for autumn. So in the autumn, we're going to have it starting to get light again at 5 in the morning. So we'll set that to 0.85. Then at 6 in the morning, we're going to set that to 0.95. And then at 7 in the morning, we're going to set that to 1. And then we're going to have things going dark again in the autumn at 7 o'clock. So that's 1900 hours. So we'll set it at 0.85 intensity at 7 o'clock. And then at 8 o'clock, we'll set the intensity to 0.5. And then at 9 o'clock, we'll set the intensity to 0.3. And then in the winter, obviously it's going to be a lot darker in the winter. So it's not going to start getting light until 7 o'clock. And that'll be 0.85. And then at 8 o'clock, we're going to have that at 0.95. And then we're not going to have it get fully light until 9 o'clock in the morning. So that's intensity 1. And then in the winter, we're going to have it going dark again at 3 o'clock in the afternoon. So at 3 o'clock, we're going to have the intensity at 0.85. And then at 4 o'clock, we'll set the intensity to 0.5. And then at 5 o'clock, we'll have it as being very dark. So we'll set the intensity to 0.15. So that's the whole schedule set up for our outdoor environment. And we've got global lights on each of our scenes. So we're going to create a light control script that uses these values in this scriptable object to control the intensity of the global lights in these scenes. But we're also going to be able to use these schedules to control the intensity of lights that aren't global lights. So we can also create spotlights. So if you've got like a lantern or a lamp, you can have a spotlight attached to that. And then we can use these schedules as well to control the spotlights. And also if we've got indoor locations like the cabin, we potentially want those to have different lighting schedules than the outdoor environment. So we'll come to that in a minute, but we're creating schedules here and this gives us flexibility so we can create as many schedules as we like and then attach those to whatever light sources that we create in our game. Okay, so let's actually create the script now that's going to control our 2D lights. So I'm going to right click on this folder, create C# script, and I'm going to call that lighting control. So I'll just double click on that to open it in Visual Studio. So I'll just go through and set up this class. So I'll just delete these standard methods for the time being. Now 2D lights are still considered by Unity as being experimental. Now they've been out for ages. I'm not quite sure why they're still classified as experimental, but to use 2D lights, you need to use this namespace, which is unityengine.experimental.rendering.universal. Now, at some point in the future, this is going to go away from being experimental. So what we're going to do is we're just going to include another namespace in here to anticipate that. And what we're going to do is we're just going to take out the experimental. So in theory, at some point, when these 2D lights go from being experimental to non-experimental, we'll have the namespace in place that will be able to identify those 2D lights. Okay, so let's Control S to save that. And then what I'm going to do is I'm going to create a number of member variables. And the first ones I'm going to create are going to be serialized fields that we're going to populate in the inspector. So the first one is going to be of type lighting schedule. So this is our scriptable object. So we're going to be able to attach a lighting schedule to this lighting control component. And then for our lights, depending on the type of light, we're going to give it the ability to actually flicker the light. So for main outdoor lighting, we don't probably want it flickering, but for like a lamp or a lantern, we probably want it flickering just to make it look a bit more real. So we'll add this boolean in here, is light flicker, and we'll set that to false initially. And then we're going to add some additional fields to help us control the light flickering. So the first one is going to be a light flicker intensity, and I've just added this range attribute on the front, which will give a slider in the inspector. And this is of type float, so we'll be able to set the values between 0 and 1 in the inspector. So this will control how bright that flickering intensity is. And then for the flickering lights, we're going to have like a min and maximum flicker time. And then in the code, we're going to generate a value between the minimum and maximum just to sort of create a bit more of a randomized flicker. So I'm constraining that between 0 and 0.2 as values. So next we're going to add a member variable actually to cache our 2D lighting. And in our scriptable object, we've created an array for our schedules. So to make that easier to access and more efficient to access in this class, we're actually going to copy those values into a dictionary. So this dictionary is going to have a key of type string, and the key is going to be made up of basically the season plus the hour converted to a string. And then the float value is going to be the light intensity. So I've called that the lighting brightness dictionary, and we'll populate that in the awake method. Then we're going to have a value for the current light intensity, which is going to be a float. So we'll use that as we calculate values. We're going to have a timer for our light flicker. So we can have a timer, and then when that counts down to 0, then we can change the light intensity to cause the flicker. And then we're going to have a member variable of type coroutine, and we're just going to use that to provide a reference to the coroutine that we're going to kick off that actually fades the light into our new intensity value. But you'll see that in a bit as we come to it. So now I'm going to create the awake method, and we're going to do 3 things in the awake method. First of all, we're going to cache the 2D light. So just use the get components, but in children this time. So if we've got a 2D light on any of the child game objects, it will pick it up. So it will pick it up if it's a component on this object or any children. So because this is a lighting control component, it's not much use if it hasn't got a 2D light to control. So what we're going to do is we're going to test to see if we've got a 2D light. And if that equals null, we're basically going to disable this component because it's got nothing to do if there's no light. There should be a light, but if for whatever reason we've got this component attached but no light, this will just disable this component. And then the last thing we're going to do in the awake method is basically populate our dictionary with the values in the lighting schedule. So our lighting schedule is an array. So we're obviously going to populate the lighting schedule in the inspector, and then we're just going to iterate through that array, picking up all of our lighting schedules. And we're just calling each iteration value the lighting brightness. And then all we do is we just build up a key based on the season, and that's concatenated to the hour. And they're both converted to strings. So we'll have something like spring 10, which is the brightness at 10 o'clock in spring. And then we just add that value to the dictionary. So we just select add, then the key, and then the lighting brightness intensity. So you might want to add some validation in here just to make sure we don't try to add a duplicate value to the dictionary. But I'll leave that as an exercise for you to do. Okay, so we need to be informed of a few events that happen. So the first event that we're interested in is when the game hour event is triggered, because we need to then check to see whether we've got another light intensity in our schedule that we need to adjust to. And we also need to subscribe to the after scene load event, because if we're switching scenes, so going from an outside scene to an indoor scene, we might have a different light schedule that we need to implement. So let's subscribe to the events that we're interested in. So we're going to do that in the onEnable method. So these are the 2 events, the advanced game hour event and the after scene load event. And these are the event handlers in this class that we're going to create to handle these events. So when this event gets triggered, this is the method that's going to get called in this class. And then where we subscribe to events, we also need to unsubscribe from them. And then we do that in the onDisable method. So when we subscribe, we use the plus equals notation. And then when we unsubscribe, we use the minus equals notation. So let's crack on and create these event handlers for these events. So the first one I'm going to create is the advanced game hour event handler. And what we're doing is we're just calling another method from this event handler. And then we're going to do the same for the after scene load event handler as well. So in our update method, what we're going to do is we're just going to decrease the light flicker timer. So every frame, we're going to decrease the light flicker timer by time delta time. And we only want to do that if the isLight flicker boolean is set to true. So we want to flicker lights on this lighting control. Okay, so let's create this set lighting after scene loaded method next. So I'll just add that below here. And what we need to do is once we've loaded a new scene, we need to get the current game season. And we also need to get the current game time so that we can then set the lighting intensity to the appropriate value. Now we've already got a method in our time manager that allows us to get our game time, but we haven't got one that allows us to get our game season. So that's what we're going to do next. So I'll just control save this and then go over to our time manager class. So let's just go up to our time system and double click on time manager. Then I'm just going to navigate down to this method, get game time. So this method will allow us to get our game hour, game minute, and game seconds. And underneath that, we're going to create a method called get game season, and that will just return the game season. It's just a public method, and it returns a value of type season. So I'll just Control S to save that, and then go back into Unity. We'll just go back into our lighting control script. So now what we do is we'll retrieve our game season. So we'll just call this method we've just created to get our game season, and we'll also get our game hour. So we can call this get game time method that's already set up in the time manager. And then we want the hours value, the hours property of that value. And then we're just saving that in this variable called game hour. And then we're going to call this new method that we're going to create called that lighting intensity. And into that, we're going to pass the game season, the game hour, and then whether we want the intensity to fade in gradually or be applied immediately. So when we're switching scenes, we don't want it to fade in. So we're going to set that to false. But for a normal time schedule, we do want that to fade between the brightness levels. So that would be true when we're adjusting the normal environment lighting based on the lighting schedule. Just Control S to save that for the time being. Okay, so now we've got two places where we're calling this set lighting intensity. So we've got it now as part of the set lighting after scene loaded, but we've also got that as part of the event handler for the advanced game hour event. So let's create this set lighting intensity method next. So I'll just create that underneath here. So this method accepts three parameters. So the game season, the game hour, and then whether we want the lights to fade in gradually or to basically not fade in and just be applied immediately. So we're passing in a game hour into this method, and we want the light intensity from the schedule for the closest hour that is less than this game hour. So for example, if we've got something in our schedule set for 6 o'clock in the morning and we pass in the game hour of 8 o'clock, we still want that 6 o'clock value. So what we need to do is, if we don't have an exact match on this, we need to basically loop through the previous hourly values for that game season and then look in our dictionary. So we basically need a loop here. So we'll set up a while loop here. So for our while loop, we basically want to get the light intensity for the nearest game hour that is less than or equal to the current game hour for the same season. So we're potentially going to have to loop for 23 times to get the correct hour. So this is our index. So we want to start off by setting our index to equal 0. So we'll specify that as an int, I equals 0. So first of all, we'll start by checking the dictionary for the season and the hour that have been passed in. So we'll build up the key for the dictionary, which is basically the game season and then the game hour that have been passed in. And then we can check the dictionary using this key that we just put together. So that's what we're doing here. We're using this try get value method on the dictionary. We're passing in the key, and any value that is returned will be returned in this target lighting intensity variable. But this try get value will basically return true or false depending on whether we had a value or not. So if we've got a value, that's great. We've got an exact match for the season and hour, so we can use that. So we can carry on to code that within this if statement here. So if we have got a value from the dictionary for our lighting intensity, then there are two cases that we need to handle. The first one is if we want to fade in the lighting, and the second case is if we just want to apply the light intensity immediately. So we can just do that with an if statement, test in the fade in value here that was passed in as part of the call to this method. So if we do want to fade in, the first thing we need to do is to check to see whether we've already got a fade in light coroutine started. So we can do that by checking this variable here, which is a reference to the coroutine that we're going to start. And if it doesn't equal null, that means there's a coroutine already started. So we just stop it. And then once we've stopped it, if it's already been started, we can then start another coroutine to fade in the light. So we'll do that underneath here. So we're just starting a coroutine called fade in light routine, and we're passing in the target lighting intensity. And then we're just referencing this coroutine using this fade in light routine, which is the one we checked up here to see if coroutine was running. So if we don't want to fade in, then we can just apply the target lighting intensity immediately. So in that case, we can just set the current light intensity to the target lighting intensity without fading it in. And then once we've handled both of these cases, we can just break out of this while loop because we've done what we need to do. So the issue is where we haven't actually got a match here for this try get value for the season and the hour. So what we have to do in that situation is we need to loop again and then reduce our hour by 1. So the first thing I'm going to do is increase our loop index by 1, just to say we're looping round again. And then we can subtract 1 from our game hour. And then when we come back round again, the key will be built with the season and then the game hour -1. And then we'll see if we've got a target lighting intensity schedule for that season and game hour combination. But we just need to handle the case where we've gone back through midnight. So if our game hour after subtracting 1 from it is less than 0, then we're actually back at 11 o'clock at night. So 2300 hours. So then we come back round into this while loop again. We build a new key using our season and then our adjusted game hour. And then we do the same thing all over again. We try and get a value from the dictionary based on this key. If we've got one, then we can process it. If not, we have to loop again for the maximum of 24 values, including the first pass through. Okay, so let's just Control S to save that. So the next thing we'll do is we'll create this fade light routine. So this coroutine under here. So coroutines have a return type of IEnumerator, and we're just passing in the target lighting intensity that we want to fade to. So the first thing we're going to do is specify a fade duration. So this is how long we want it to take to fade to the new light intensity. So I could set this up in the settings file, but I'll just leave it here for the time being. And then we want to calculate how fast we want that fade to be based on that fade duration. So we just use that formula, distance equals speed times time. So speed equals distance, which is the difference between the current light intensity and the target lighting intensity divided by time, which is our fade duration. So that'll give us our fade speed, and we just want the absolute value of that. So we don't really mind which one of these values is larger. We just want the absolute fade speed. And then we want to basically loop until we've actually faded in completely. So we use this mathf.approximately function. So we continue looping while these two values aren't approximately the same. So we specify two values into this approximately, and it tests them to see if they're approximately the same. So while they're not approximately the same, we want to carry on step by step, fading towards our target lighting intensity. So we can do that by using this mathf move towards function. So for this move towards function, we specify our current value, our target value, and then the delta of how much we want to move between the two. So if you just look at this move towards method, it says moves a value current towards target, and then it basically returns the new value. So we basically just use that to move towards our target lighting intensity, and then it returns the new value into our current light intensity. So we basically carry on through this loop until the current light intensity is approximately equal to the target lighting intensity. But for each cycle of this loop, we want to yield return. So we don't want to do this all in one frame. We want this spread out over a number of frames. So we've seen this before with coroutines. So we just yield return null. So it'll jump out of here and then come back in when the next frame processes until this while loop is satisfied, and at which point then we'll jump out. And then as we jump out, we just do a final set of the current light intensity to equal the target lighting intensity, because these two values potentially are going to be slightly different. So we just then set the current to equal the target. So that's sort of our main fade-in routine. So if we just go back up to the update method. So in the update method, we're basically reducing the light flicker timer, and we're going to add another method here called late update. So late update basically happens after all the other callback methods are processed, or the main ones that we're concerned with anyway. So in this late update method, we're going to handle the flicker or set the light 2D intensity. So the reason we're doing this in late update is we basically want to sort of set the 2D light intensity at the very end. So there are going to be two cases that we're interested in. So first of all, if our light flicker timer is less than 0, in other words, we can now flicker the lights, and we've got the isLightFlicker boolean ticked, then we want to basically flicker the lights. So we're going to create a new method in a minute called lightFlicker, but we'll just call that here. Alternatively, we just want to set the light's 2D intensity to equal the current intensity, which I can then just do here. So after fading in and adjusting this current light intensity, at the very end in late update, we're just then setting the light 2D intensity to that value. But if we are ready to flicker, then we want to basically flicker the light, which means also adjusting its intensity. So let's just go to the bottom. We'll create this light flicker method. I'll just create that at the end here. So the first thing we want to do is just create a random flicker intensity, and we'll just set our light 2D intensity to that. And we're going to calculate that flicker intensity around the current light intensity value. So we're going to have a random range between the current light intensity, and then we're going to basically adjust the current light intensity by the light flicker intensity. So we'll take our current light intensity, we'll multiply it by our light flicker intensity, which is a decimal value, and then we'll just add that to our current light intensity. And then we calculate a random range between these two values. So that'll just give us an increased intensity, or a random value for the increased intensity based around the current light intensity. And we just set the light 2D dot intensity value to that in this light flicker routine. So that's the light's 2D intensity set, either as part of the flicker based around the current light value, or alternatively, we've just set it up here in the late update. Okay, and then the last thing we want to do in this light flicker method is we want to reset the light flicker timer. And we basically just set the timer to be a value between the light flicker timer min and the light flicker timer max values that we set in the inspector. I just calculate a random value between those two, and that just then reallocates it to the light flicker timer, which then will get counted down again in this update method until it's less than or equals to 0, at which point then we'll trigger another flicker. Okay, so it's just Control S to save that. Okay, so let's return to Unity. Okay, so we've got our lighting control component now, and we've got our lighting schedule that we created for the outdoor environment. So now what we need to do is we need to add the lighting control component and this schedule to our outdoor scenes. So let's just load our farm scene and then go down to the global light 2D. what we want to do is we want to add the lighting control components to this. So let's just go to add components, search for lighting control. And then in the lighting control, we want to add the lighting schedule that we created. So we can just drag that across. And then for this outdoor lighting schedule, we don't want the light to flicker. So we won't tick the is light flicker box. So I can just Control S to save that. Unload it and then load the field scene. And I want to do the same for that global light. So we'll add the lighting control component and we'll drag across the outdoor environment lighting schedule. I'll just Control S to save that. And I'll just unload the field scene. So we shouldn't have any scenes loaded. So now if I start the game, we should see the main outdoor light fade in and getting darker as we get later. So let's test that out. So I'll click on the play button. So here we are at 6:30 in the morning and things look pretty bright. So let's just advance the time using the T key, the test time advance key that we set up. So I'm just going to advance the time to say 4 o'clock, just after 4. So now if we just wait a little bit until 5 o'clock, we should see it getting slightly darker at 5 o'clock. Okay, and it is getting slightly darker. It's just subtly at the moment. So let's go through to 6 o'clock now. And then we are at 6 o'clock, it's going darker again. Then if we just go through to 7 o'clock, that should be the darkest for the spring schedule. So you can just about see the player. Now we haven't got any other lights in this scene now, so it's quite difficult, but that's what we're going to do next. We're going to add some lights. But if we go into the cabin, we didn't actually set a lighting schedule for the cabin. So the cabin is still fully lit. So this is where these schedules are very useful. So you can actually control different scenes lighting using the schedules. So I go back outside, it's pitch black. In the cabin, it's fully lit at the moment. So if I just advance the time through to the morning, I think we started getting lighter about 6-ish, didn't we? So there we go. So it's starting to get lighter again now, at 5-ish. And then at 6 it will get even lighter. So I think that's probably fully bright by 7. So that's working really well. So we can just check that for the field as well. So if we go over to the field, we set that to use exactly the same lighting schedule. So I can just say skip through to 6:40 and you can see that going darker again. And then at 7 o'clock it goes the darkest it's going to get. And we'll just skip through to the morning again now to let it brighten up. So that's our light schedule set up for our day-night cycle. So that's great. I think what we should do now is we should create some lights just so we can see our way around when it's dark. So let's just quit back to Unity. And what we're also going to do is we're going to create a lighting schedule for our cabin. So what we'll do is we'll duplicate our outdoor light environment. So we'll just Control D. And then we'll call that lighting schedule indoor cabin. So I'm going to leave the indoor cabin to be the same lighting as the outdoor environment. So as it gets darker outdoors, it also gets darker indoors. But what I'm going to do is I'm going to create a lamp for our table for our cabin to actually illuminate the cabin. So I need to import a sprite for the lamp. So I'm going to go down to sprites, sprite textures. And then I'll go down to the objects folder. And then I'm going to import a new asset. And I'm just going to import this lamp. And then for the lamp, I'm just going to set the sprite settings as we've set them in the past. So pixels per unit we'll set to 16. I'm going to set the filter mode to point and then the compression to none. Then I'm going to set the pivot for the sprites to the bottom. And then I'm going to create a prefab for the lamp. So I'm going to go up to this prefabs folder. Just apply the settings for that sprite. And in the prefabs folder, I'm going to create a new folder. I'm going to call that lighting. And then I'm going to create a new prefab in here. So create prefab. And I'm going to call that table lamp cabin. I'll just double click on that to open it in the prefab view. So the first thing is we're just going to add a sprite renderer. And then I'll find the lamp sprite. And you can see by default now the material that is being used is the sprite lit default material. So that's correct for our universal render pipeline. And we'll set the sprite sort points to pivot, which is at the bottom. And we'll set the layer to instances, and we'll set the ordering layer to 1. And then we can add our lighting control components to here. So we'll add component lighting control, and we need to create a schedule for the lamp. So we could do that now. So let's go up to the scriptable objects. So I'll just right click, create scriptable objects, lighting schedule. I'll call that, what should I call that? I'll call that indoor lamp cabin. And then I want to create some values here. So we'll create a first entry for spring, and we'll say at 6 o'clock in the morning, the lamp has an intensity of 2. And then we'll say at 11 at night, the lamp has a intensity of 0.8. So we'll leave the lamp on, but at a lower intensity. So that's spring. And we'll do something similar for summer. So we'll have it coming on at 6 o'clock with an intensity of 2. And then we'll have it going off at 11 o'clock, or we'll reduce the intensity at 11 o'clock to 0.8. And we'll do exactly the same for autumn. And we'll do the same for winter. Okay, so let's just go back to our prefab, our table lamp cabin, and we'll just pick up that lighting schedule we just created. So indoor lamp cabin, and we will have this light flickering. So we'll click the is light flicker box, and we can just adjust the flickering sort of brightness here. So we'll have it about there, midway, and we'll have, you can just play around with these values, but I'll just set it to that. That's fine. So that's our lamp prefab with our sprite renderer and our lighting control script. But then we also need to set up a light source. So I'm going to create that as a child here. So I'm going to create a light, then a spotlight 2D. And this is going to be a spotlight. And then I'm just going to adjust the values here. So I can adjust the position of the light. So if I just zoom in here, you can see the circle where it's positioned. So we don't want the light to be positioned at the base. We want it to be positioned up in the lamp. So I can just adjust this Y position here to move it up to, I don't know, about there. And then we can change some of these values here. So the intensity, it doesn't really matter because that's controlled by our lighting control script. And then you can set sort of like the inner radius of the light and the outer radius. So I don't know, we'll set the inner one to 0.2 and the outer to 4.3. And we'll just have the fall off strength set to about 0.67, that should do. We want to target all of the sorting layers for the light. We don't need to change any of these values. So that should be everything we need to do for the light. We can change the color of this light, so we could give it a bit of a warmer yellow sort of glow. So let's stick with that. And then we just need to put this prefab in the cabin and position it on the table. So we'll just load the cabin scene. Just zoom in. And then we'll just drag this prefab into the cabin scene. Then we can just adjust that using this positioning control here. So we'll put it on the table. So let's just save that scene, Control S. And then we'll just unload it. Let's just play the game again and then set it to be night. So if we go in the cabin now, you can see the light is on. Now if we just skip forward in time to the night, so everything's getting dark outside. Now if we go in the cabin now, you can see our light is set even brighter. And then if we skip forward in time, we should see that light going down in brightness. So I don't think we're picking up the right global lighting schedule for this cabin. Let's just check that out. So let's just stop that for a second. So if we just load the cabin again, and then go to the global light 2D. Right, okay, so we haven't set the light control for the cabin for the global light. So let's just do that now. So let's just add component, lighting control, and we want to set the indoor cabin lighting schedule on this global light. So I think that's everything we need to do. We don't want it flickering. Okay, so let's just save the cabin again. We'll unload the cabin. Press play. So if we go and make it dark now, let's go forward in time. Ah, that's better. Our cabin's dark inside now, but we've just got the lamp light that's shining. And it's very dark outside. So that's looking good. So this is a really good example how you can control lights in a 2D game. So what we're going to do now is we're going to create some outside lights here, just so our player can see what he's doing at night. So let's just stop that. What we're going to do is we're going to create like a pumpkin jack-o'-lantern to put outside. So I'm going to create that as another prefab. So let's just create a prefab and I'll call that jack-o'-lantern. And we need to import a sprite for that. So let's just go back down to objects and then import new asset. And we've got this jack-o'-lantern sprite. So we'll just import that. And then we'll just set its values here. I'll set a custom pivot for the jack-o'-lantern. So let's just set this custom pivot to be about there. I'll apply that. So we've set the pixels per unit to 16. We've set a custom pivot point. We'll set the filter mode to point. And then we'll set the compression to none. So I'll just apply that. If we just go back to our jack-o'-lantern prefab, I'm going to add a sprite renderer. And then I'll just add the jack-o'-lantern sprite. So we want that to be on the instances layer as well. I'll leave that as a value of 0 for the ordering layer. And I just need to adjust the scale because this sprite is quite big. So I'm just going to set that down to half size. So that should be the sprite setup. And then what I'm just going to do here is I'm going to add the lighting control component. And we do want it to flicker. And we'll have maybe a higher intensity and then a very small value on the flicker here. So it flickers more. So that's our lighting control setup. And then we just need to set up the actual child 2D light. So I'll create a light spotlight, light 2D. And then for this, we'll set the Y value to be slightly higher up. So just very slightly. So just adjust that upwards to be, say, about there. And we could change the color to be sort of more of an orangey color. The light. And then the intensity, that's controlled by the lighting control. So we don't need to worry about that. And then for radius, I'm going to set the inner radius to 0.48. So these are just values I found worked for me. And the outer to 4.94. And the fall off strength, I'm going to set to 0.94. We want it to target all of these sorting layers. So Control S to save that. And then what we need to do is we need to create a lighting schedule for this jack-o'-lantern. So I'm going to create a new scriptable object for our lighting schedule. And I'll call that outdoor. Let's call that outdoor light. And then we just set up the values for that like we have before. So we'll start off with spring. So at 6 o'clock, we want the light intensity to be 0. So we don't need the lights, the outside lights on beyond 6 o'clock. And then we just sort of need to match when these come on with the outdoor light schedule. So for spring at 5 o'clock, we're going to have 0.5 intensity. And then at 6 o'clock, we're going to have an intensity of 1. And then at 7 o'clock, we're going to have an intensity of 1.5. We'll do a similar thing for the summer. So we'll have the lantern going off at 5 o'clock, so 0 intensity at 5 o'clock. And then we won't have the lamp coming on until later. So we'll have it coming on at 9 o'clock at 0.5 intensity. And then at 10 o'clock, we'll give it an intensity of 1. And then at 11 o'clock, we'll go to 1.5. Then we'll do a similar thing for autumn. So for the autumn, we'll have the light basically going off at 5 o'clock, so 0 intensity. And we'll have it coming on at 7 o'clock, so 1900 hours at 0.5 intensity. And then 8 o'clock, we'll give it an intensity of 1. And then at 9 o'clock, we'll give it an intensity of 1.5. And then we'll do the same for winter. So for winter, we'll have it going off at 7 o'clock in the morning. And then we'll have it coming on a lot earlier. So it will come on at 3 o'clock. So we'll set that to 0.5. And then at 4 o'clock, we'll set that to 1. And then at 5 o'clock, we'll have that as full intensity for us, which is 1.5. So that's the schedule for the lamp. And then we just need to go back to the prefab and then add that schedule in here. So we go to the lighting schedule and then we'll just select the outdoor light. So that's our prefab setup. And then all we need to do is add that prefab into our farm scene. So I'll load the scene and then select scene asset. And then I just want to basically drag those lanterns into the scene as part of the scenery. So if we just go to the scenery folder, just create a new subfolder in there or a new parent game object called lighting. Keep things organized. And then I want to drag the lamps into there. Then I can just position them wherever I want them to be. Let's put some. So I don't think we've quite got the sort points set correctly here. So let's just go back to that prefab. Check out the sort points. Yeah, so the sprite renderer we want set to pivot, not center. So let's just go back to our scene. Okay, so that's better. Okay, so we'll set one there. Then we can Control D to duplicate it, and then just move them to some locations that we want. I'm just going to drag that across to give us a bit more room. So Control D. So I'm just duplicating these and then moving around just to give us a bit of interest. Put a few random ones over here as well. Probably enough for our demo. Let's put a couple up here. Okay, so that's probably enough for our farm scene. So I'll just Control S to save that, and then unload it. And then I'll do the same for the field scene. So let's just load the scene. And I'll create other game objects in here. So create empty. Let's call that lighting. And I'll just add the lamp into there. And then I can just drag this around like we did before. Control D to duplicate it. Okay, so that's good. So let's just save this scene, Control S, and then I'll just unload it. So let's just run the game and see how that looks. So I'll just Control S first, and then I'll just press play. There's all of our jack-o'-lanterns, so you can't really tell that they're lights at the moment because the lights, I think, go off at 6 o'clock. But as we increase the time, so let's go to just before 5. So things should start getting darker at 5. So you can see the light starts fading. And now we've got the lanterns starting to flicker a little bit. So that looks really quite nice. And then at 6 o'clock, it's going to get even darker. And you'll see as we hit 6 o'clock, our next lighting schedule kicks in and things go quite a bit darker. And we've got our flickering lanterns to help us navigate. And then if we go to, say, 9 o'clock, where it's going to be completely pitch black, or as dark as we've set it, you see now we've got the lanterns. So this looks really effective. We're using the 2D lights. So I think you can see now the power of the 2D lights, and even this sort of simple system that we've created gives us quite a lot of flexibility. I think they need to invest in some more lights for their cabin because it's a bit dark in there. So this is the effect that we wanted, and it's, you know, we've got a day, night and season cycle. So maybe that's just something we want to just have a quick look at now. So let's just skip ahead and see if we can get into a different season now. Okay, so now we're in the spring season, summer season. Okay, so for summer, things get lighter earlier and darker later. You can see now it's 10:30, but it's still not pitch black yet. I think we set it to go sort of as dark as it's going to get at 11 o'clock. So that should go darker at 11. That's 11 o'clock now, and it's going to go darker. So our lighting day-night cycle is also adjusted for the different seasons. So if we skip forward, I think it was going to get light at 4 in the morning, wasn't it, for summer? There we go. So it's getting lighter again. If we just head over to winter, so press the G key to advance the days. So let's just go into winter. And in the winter, it got dark very early, I think about 3 o'clock. So we're in winter now, so let's just skip the time forward. So if we skip the time forward to 3, now in winter, you can see it's starting to get dark again. Go to 4, it's going to get even darker. And then at 5 o'clock in the winter, it's goes very dark. Okay, so that's it. So I'll just press escape to get out of here. And I'll just reset my course layout. Just collapse everything out. So that's how we set up a day, night and season cycle for the lights. So I hope you can see how this can be useful, and you can set up different schedules for different global lights. So you can control whether it's an outdoor scene or an indoor cabin or an indoor cave. And you can obviously use these spotlights to create lighting effects that you can then put into your scenes. So I hope this has been useful, and thank you for following along, and I'll see you next time.